So, hi, well, the introduction was perfect because this is going to be the core of our talk. We are going to talk about the Spark runner and how it evolved into portability. But to do this, we have to give a little bit of context for the people who are not familiar with the Beam model and the Beam goals as a project. So, I am Ismael Mejia, and he's Kai, the guy without picture. We both work at the project. I have been for some months, for some years already in the community. Well, let's start. So, as an agenda, we have 3 sections in the talk. The first one is a little bit of presenting how the Beam model works, why some things are as they are, and what are the goals and where we are with these goals. Second one is about the Spark runner, how the Spark runner works in the classical translation that we did before portability, and how this is reused by the portability afterwards. And well, the third part is connecting the dots of the portability APIs with the Spark runner. So, a little warning, just this, we assume basic knowledge of big data, basic until the word count level, so it's not that high. And well, how many of you have used the Spark before? Just no, 70% maybe, so that's good. Okay, so we will show some of the Spark APIs, and just to show how we translate things into Spark, and then you understand how this works. So first, well, we're going to talk about the Beam model, and in the Beam programming model, we have the representation of a collection of distributed data that we call API collection from parallel collection, and then comes from an input that can be a distributed database or a pub subsystem, and then we apply transforms to this. Yeah? And each transform may filter data or re-window data or do some stuff, and in the end, we're producing a graph like the one on the right. And the API is quite straightforward. In general, we have a API collection, and then we apply transforms, and we connect these transforms to produce an output. One important point is that these transforms are usually, they're coherent with map and combined transforms from MapReduce and other things, but most of the time they are configured or parameterized by user-defined functions. This is key to understand to understand why we can translate on Beam from Beam to Spark or to whatever engine you prefer to use. So let's go with the basic word count. The idea here is that we want to count words, and this is a traditional map shuffle reduce steps that we do. And the idea, we want to count words, so we produce a pair of key values with a word and the number of occurrences. Then we have this shuffle phase where we group these words into a same machine, so we can then group them, and this is what we do in the reduce phase. This is how it works since the Hadoop days, so it's quite straightforward for most of you. So in the Beam side, we do this with 2 operators. One is pardo, that is our map on Beam, but it's like a batteries included map, huge, it's superpowers, it's like super big. And then we have this transform that is quite specific, as you can see, some integers per key. And well, the idea is that there is a lot of transforms in Beam that are composed by other transforms. So if we see this in the programming model, again, we have these applies that connect things. But more important is what I mentioned before, that we parameterize functions provided by the users to do the different transforms. So in reality, this sum integers per key transforms is a composition, or can be expressed as a composition of 2 things, that is group by key and a pardo that is going to do the accumulation. And this is important because the Beam model has a good amount of transforms that are there to be user-friendly. But we have really primitive transforms that are essential for the model and are really important for the runner's authors. That is the case we care about. This is how this expands. So of course, this is really verbose compared to the other version. But well, that's not a problem for the end user, but this is what happens inside in the first expansion. And then from this we go into the native language, native framework, Spark in this case. So, but well, Beam is not only MapReduce. This is what makes interesting Beam, because well, Beam covers also the streaming part. And to cover the streaming part, well, if each element in Beam has an associated event time stub, that allows us to decide, plus other elements, for example, that is like windows or triggers, that allows us to decide when to compute things, when we materialize results. This is the usual trade-off of waiting for more results or having an answer before. So all these elements are key to, and this adds more transforms to the Beam model, and for the translation of the Beam model especially. So this is a list of most of the transforms we have in core SDK. This is the Java case. And also, well, the things to define windows and triggers. And as you can see, there are too many. If we were translating all of these cases for when we create a runner, we will be really in trouble because it's too much. But in reality, we just care about 5 transforms that are the primitive transforms of the Beam model. So we have the read transform that allows us to read collections in parallel from different partitions, for example, of a database. We have the Pardue transform that is our map transform. We have group by key that we already mentioned. We have flatten that allows us to do union of P collections, and we have a transform to assign windows. I'm going to explain all of them in the Spark context right now. So, but first, just let's remember that the vision of Beam, the idea is that we want to translate from different languages into different execution systems. As Max mentioned at the beginning, well, doing this with Java is quite straightforward as the way we have done it in the past. And this works like this, actually. A runner writes their program, a user writes their program in Java, for example, and they send this to the runner. The runner task is just to translate this. So translate how? Well, if I have a Pardue, I transform this into a map in the target system. And in the end, all these user-defined functions that are parameterize the pipeline end up being executed in the execution engine. So a part of this, well, runners are responsible to translate these primitive transforms, but they are also important to keep the consistency of the Beam model. And what does it mean? Well, we have to propagate the progress of the watermark. We have to choose when to close windows, when to drop data, when to emit a state, timers. It's quite tricky to do all of this. And in the case of the Spark runner, well, we're going to give a little bit of historical context on the Spark runner. So, well, somebody can ask the question, why should I care to use Spark if I can use other framework, for example, with Beam? Well, the first answer is because it's the most popular framework still out there. Also because it supports most of the resource managers, like you can run Spark on Hadoop, but also now in Kubernetes, so it's good. Also, there is a rich ecosystem of tools around Spark that we shouldn't doubt that is important. I mean, for example, the Apache Libby is one project when you can use to submit pipelines with a REST API. There are projects also to monitor Spark or Hadoop clusters too, like Baobab from Criteo. Even you can run these Spark jobs in a serverless way with Databricks. So there's still valid arguments to use Spark as a destination system. And the Spark runner was introduced into the Beam community really early on, 2014, 2015. It was donated by Cloudera, and it's one of the most battle-tested runners in Beam because it has already passed all the validation runner test suite that we have, and especially because our users from all of these companies or contributors have bring suggestions or errors or have found things that we don't optimize correctly. So if you care about maybe understand the story of this optimization, there is a presentation from the last Beam Summit where we show each one of the cases we have improved in the last year. And well, as you can see, we have been contributors from different companies involved. So just a little bit of context on the Spark runner before we visit the translation process. Spark has this abstraction called RDDs, that are Resilient Distributed Dataset. RDDs are a little bit like Beam's P collection. There's a way to represent distributed collections. We also have something that is different in Spark, is that we have transformations that actually just apply that don't materialize data. the result. We just applying one function, and in the graph, if we want the results, we have to execute an action. We also have in Spark this concept of broadcast variables, that they are read-only variables that we can get in the different executors. Why this is important, we will see it later on. And finally, in Spark, we have the Spark context that is a fine-grained way to control the execution of our job. No? I forgot to mention something in the previous slide, is that in the case of this current Spark runner, we only use the RDD and the stream APIs. We don't use dataset and data frame, that are the more recent ones, because of historical reasons, because it started with these APIs and we were continuing iterating with those, but also because they were not evolved enough at the moment, and also, well, in some cases they are not even finished, like the data source API that's still evolving in Spark. So let's revisit the transforms that we said that are primitive in the Beam model. So we are going to see a little bit of how we do to get this into Spark in a Spark way. So the first one is the read transform. The read transform allows us to read in parallel from different workers and from different partitions. And the most important thing is that this transform is configured with a source. For example, I want to read from, let's say, a distributed file system. So I have a way to do that I know is going to split correctly. So this is all the Beam API that does that. But a key thing is that internally, if you have an element, internally we represent this element as a window value. What is a window value? Is your value, your initial value, plus the event timestamp that is somewhere, plus all the windows where this is assigned to, and the pain info to see if we trigger or not the things. But if I think on this in Spark terms, well, this is quite similar to producing an RDD from a configuration that is the source. So we do this by creating a Java RDD from our source. This is just how it works in code, where we just parameterize the thing with the RDD with the source, and then we do the partitioning using the Beam API. We rely on the internal Beam API, and sources in Beam produce readers, and these readers are translated in the compute method when they really execute in the Spark front. This is pretty straightforward way to translate the read transform. Then we have the Pardue transform. The Pardue transform is really, really tricky. It's not just per element processing. It has to enforce also the fun life cycle. So if you have seen this thing, well, you have setup, start bundle, process element, finish bundle, and tear down. The runner also has to decide the site of these bundles that are like group of elements that will change if it's batch or streaming to optimize the execution. It also has to support, multiple outputs, side inputs, state, timers. I got to the conclusion after preparing this slide that you can do a 40-minute presentation of the Pardue transform and it wouldn't be enough. It's quite tricky. So just to show a little bit of how we do in Spark, in reality we rely on two methods. Is the flat map from Spark and the map partitions method to respect the life cycle in each worker. And also for side inputs, we utilize broadcast because side inputs are P collections that are materialized in each worker, so we can access them. That's like a high view of how it does it. Then we have the group by key transform. And again, this is another one where things are not just group by key. There are some more things that happen. When we group by key, actually, we need to do more things when we have event time to be coherent with all these event time computations of the model. So we have to merge windows if we can. We have to adjust timestamps if we have multiple inputs, for example. Really interesting, we have to drop data that is expired because it doesn't make any sense to move data into a different place if it's already expired. So it's not just group by key. And also we have to decide if we emit the results or not based on the trigger configuration. In Spark, this is done by a series of maps and some internal utility classes that are part of the Beam runner's core module. And they do all of this. And finally, we do that group by key. But this group by key, as the title says, not just group by key, but by window. So we create an artificial key that is the concatenation of the key and the window, and so we get all the elements in the right place. The next transform is assign windows. This is one of the easiest to explain. We just for one element, it can belong to multiple windows. For example, in this case, these are session windows. So this element is in 3 different places, but the other one is just in 2. It's quite straightforward to translate. It's just a map that is going to produce the number of the windows where the element is assigned. And finally, well, the union of P collections is flattened, and this is a transform that exists in Spark with the union method. So all of this were the primitive transforms, but also the Spark runner optimizes other 2 transforms. And when we decide to translate a non-primitive transform, is just to get improvements. In the case of combines, well, it's optimized to benefit of combiner lifting in the Java class, in the Java case, and to create less objects, for example, in the group values case. And the reshuffle transform of Beam also is translated with repartitioning from Spark. So with all of this, we got the runner in the traditional translation manner, and but this runner doesn't have portability, and that was the state where we were last year. So at the end of the year, all the runners were starting to catch up with portability, and especially the Flink runner was one of the most advanced ones there. So well, that's where there was a point where we needed to do something, and then it's where the portable Spark runners story starts. So
great, thanks, Ismail. Okay, yeah. So where we left off, we're making the Spark runner portable. So let's go. We have our example pipeline, but now it's in Python. It looks pretty much exactly the same as the one in Java, aside from the syntax differences. We have our same functions. We have a flat map, a map, a combine per key, and so you can see that when we have this Python pipeline, there are basically 2 big challenges here. The first is we have to get this Python pipeline into a form that we can run on a Java-based runner, because we don't want to have to rewrite the entire Spark runner. That's just way too much work. And then the other thing is that we also have inside these map functions here, we have these Lambda functions, which are Python code. And the challenge there is going to be, well, how do we run those again in a Java-based environment? And so most of what we talk about when we talk about portability is really just those 2 big things. So this is the portable Spark runner, kind of the current state of things. There's a bit of new stuff as far as the code base goes, but a lot of things were actually pretty much already there, because as Ismail mentioned, we have a Flink runner that's portable and has reached a relatively high level of maturity. So we can leverage a lot of that code in our new portable Spark runner without having to reinvent the wheel as far as portability goes. So that was huge in this effort. And we can also reuse a lot of the APIs that the old Spark runner did before. So between those 2 things, it's like a lot of the pieces were already there, and we just kind of had to put them together. The portable Spark runner, as Ismail mentioned, is still based on RDDs. There is another parallel effort going on right now to use the new Spark streaming APIs, but we'll see about that in the future. And then it's been around since Beam 2.14, and I think 2.16 is getting cut today. So it's still relatively new, still relatively untested, but here it is. So we have so these are our same primitive transforms as we saw before, and we can see that a lot of them actually haven't really changed from the old Spark runner. Namely, group by key and flatten are pretty much the same as they were before. They're pretty much doing the same stuff. So then read, splittable do fun is something that I'm not going to get in here because that's like a whole nother can of worms. So I'll mostly focus on the executable stage, which is what's going to end up running your user-defined functions. So this is a really, really high-level overview of the portability architecture. So basically how it works is the SDK, be it Java, Python, Go, whatever, is going to translate pipelines into a proto-buffer representation, which is basically, pretty much any language in theory that has protocol buffer bindings could implement a Beam SDK. So there are lots out there that haven't been implemented yet if that's something you're interested in. But yeah, so once we have our protocol buffer, we're going to send it to this job server. And basically what the job server's role in this is going to be to basically receive the job. It's going to then request artifacts from the SDK. And when we say artifacts, we're basically talking about dependencies, so code. And then what it's going to do is it's going to translate your pipeline into Spark and run it on Spark. And yeah, so this is a little bit expanded. So before we just had Spark here, but now we've expanded it out a little bit to see what's going on. So basically what's going to happen is as the pipeline's getting executed, it's just going to go along, and everything, all of the quote-unquote native Spark transforms, like the group by key and the flatten, the stuff that didn't really have to change from the old runner, well, that's like the task 2 and task n here, where they just run on Spark. They just use the Spark APIs directly. But then for our executable stage, which is what's running our user-defined functions, that's where things get a little more complicated. And by a little, I mean like a lot more complicated, to be honest. But so basically what we're doing is we're using the fun API that Max mentioned earlier, and there's really never been anything more fun. I know it's a cheap joke, but basically it's going to shell out this work to an SDK harness, which is, the SDK harness is like the key piece of portability. That's what enables us to run like those Python lambdas we saw earlier. The SDK harness is what's really key in running those. So let's get into the weeds a little bit here. So the executable stage is just a Spark flat map function, really. It's like maybe the world's most overloaded Spark flat map function, but that's all it is. So it's, like I said, it's going to handle your Pardoos and all of the related machinery that Ismail mentioned earlier, with side inputs, which are still going to use Spark broadcast variables, and it's also going to handle watermarks and stuff. But as I said, we only have batch right now, so that's relatively simple. And then the other thing about executable stage is because we're going to shell out this work to an SDK harness here in a second, we don't want to have more of these than we need to. So to reduce that overhead, we're going to fuse a bunch of these steps together. So wherever we can, we put together user-defined functions into one executable stage, so it can all just be done in one pass, as opposed to multiple. So now it's going to send work requests and data to the SDK harness. And this is the SDK harness. It's basically it's provided by each SDK. So when you're implementing an SDK in Beam, this is one of the pieces you need. So we have them for Java, Python, and Go, as I mentioned earlier. And basically what it's going to do is so the runner, or the executable stage function, is going to send it work requests. And then the SDK harness is just going to go ahead and do that work. And in the process, there's, of course, it's a little more complicated than that. So we have, you can see on the right over there, we have these 5 channels where basically different kinds of data are going to be passed along. But essentially, we just need it to process data, and then it might need additional state from the runner, such as side inputs or user state, so it can request that, and it will also send back progress reports and logging and things to that effect. So the SDK Harness, we have a bunch of different options because we know there are a whole bunch of different ways that you might end up deploying your pipeline, a lot of different environments that's possible in. So the SDK Harness can run in a Docker container, it can run in a dedicated process, or it can run embedded in the runner in the SDK, if the SDK and the runner share the same language. So there's a lot of options here. There's a lot of different ways to configure this. But a lot of this complexity is not really something you don't have to worry about unless you have a custom deployment story. And this is one of the things with portability that we're kind of still working out, is how to make deploying the SDK Harness really easy. So this is the big picture, is a bit of a recap. So you can see we have our Python SDK. We're going to translate it to a protobuf, send it to the job server, and then it's going to go to the Spark cluster, and then the Spark cluster is going to shell it out to an SDK Harness. Don't get too bogged down by the details. That's basically all it really is. So we have our compatibility matrix here, which is just basically indicating the kind of features that we support right now. So as you can see, we have batches basically reach parity with the Flink runner, which existed before, but again, streaming is still missing. So we're passing tests. We're integrated with the CI and whatnot, and so now when we have new PRs in Beam, we're going to validate them against both the legacy and the portable Spark runners. And the really cool thing about all this is, so far I've only really been talking about Python, but we can also run Go pipelines now on Spark, and we basically got that for free because Go is using all of the same runner API that the Python SDK was, and because it keeps that contract, really no additional work needed to be done, essentially, to add the Spark runner to Go. So that's really cool, and that's really kind of where portability becomes really, really useful. And I'd like to mention as well TFX, which is one of the use cases for this, the Spark portable runner. I won't go into it too much because I think Charles is giving a talk on it tomorrow, I believe. But it's basically an open source end-to-end platform for deploying ML pipelines. And several of the TFX libraries use Beam Python for running tasks. These are some pretty complex pipelines, but thanks to portability, we can run TFX on Dataflow, Flink, and Spark with no code modifications to those pipelines. You basically just, instead of starting up a Flink cluster, you start up a Spark cluster, and you just point it to that, and it's basically just that easy. So if you want to learn more, you can go to that talk tomorrow. And so we'll go into a little bit of what's next for the Spark portable runner. There's still a few features that we're missing, and mainly testing is one big thing that we have to improve. Streaming support is obviously a huge thing that I mentioned, and then performance analysis. So better testing, better documentation, and then better usability. We're working right now to, like I mentioned, the job server component. We don't want most users to have to worry about starting their own job server, so we're going to end up scripting that out at some point very soon. And then another thing is, like I said, deployment is kind of one of the things that we're still working out. So we want you to be able to use this, in Kubernetes, like in a cloud or wherever. So we're going to look at adding some features to enable that. And then Spark 3 support is also going to be coming. And then if you still want to learn more about Spark, we have another talk on this today about the Spark structured streaming framework and how Beam's using that. And if you want to try it out, if you are feeling brave, you can go to this URL here and contribute, code, ideas, opinions, complaints, whatever. Yeah, so that is pretty much our talk. So thanks, everyone.